In this example, we're going to solve this inequality, and then we're going to write our solution in interval notation. Now, if you haven't taken Math 30-1, some of this example might be kind of new to you. So follow along the best you can, or at the bottom of this lesson, you'll see that we also have a review on factoring a cubic. It might be helpful to watch that video before you watch this one, just if we need to figure out how we're going to factor something like this. Okay, so as we're looking at this, what I might like to do, if this was me, is I might like to roughly sketch this thing out. So it's a cubic function. Our leading coefficient is negative. So this graph would do something like this. Okay? And we are interested in the intervals where this function is above 0, like it is over here, and where it's below 0, like it is over here. Okay? So what we're going to want to do is we're going to want to factor this function first, and then we're going to be able to test some values to see whether or not the function is above 0 or below 0. Okay, so let's write down the function again. So we've got negative 2 x cubed minus 4x squared plus 10x plus 12 is greater than or equal to 0. Okay, so if you're coming from Math 20-1, then the best we can do is we can factor something with a squared term, right? And this one's a cubed. So this is going to take a different strategy. So one thing we can do, though, that should be familiar either way, is let's factor out what's common to each term. And I can see that there's a 2 in every one of these. So I'm going to factor out, well, negative 2, just so I don't have that leading coefficient being negative. So I've got negative, and then what I'm going to have left here is x cubed plus 2x squared minus 5x minus 6. And now I'm going to say, so this is greater than or equal to 0. Okay, so now this looks a little easier to factor. And the way we factor this is we're going to take advantage of the integral 0 theorem. And what that states is that if one of my zeros, right? So if one of my zeros of my function actually is a 0, then when I plug it in for x, it should come out as 0. Okay? So if I plug in, let's say just for a minute, like if I plug in 1 for this, right? And this is one I'm kind of assuming might be a 0, maybe. Then if I plug that in, then that should come out to 0 because that actually would be like a place on the x-axis. All right, so now which numbers do we test though? So the numbers that we test are going to be the potential, or they're going to be the factors of negative 6, and we call those our potential zeros. All right, so here's what we're going to do. We're going to test out just this part of the function for now, because it would work with the negative 2 as well, but we'll just focus on this because we want that to come out to 0. So what we're going to do is just try some numbers, and let's write down what our numbers might be. So factors of negative 6, so that could be plus or minus 1. That could be plus or minus 2, plus or minus 3, or positive or negative 6, right? So I could try all of these numbers. Those are numbers that could be zeros of my function. So let's try that. So we'll say P of, and first off, let's try 1. So if we threw 1 in for, like I said, just this function, because I don't need the negative 2 involved in this. So if I try 1, then here is what I get. So putting 1 in for x's, we get negative 8. So that means when x is 1, y is negative 8. So that's not a 0, right? That's not a factor on my function. So then we keep trying. So then we're going to try negative 1. So negative 1. So then this would be negative 1 cubed plus 2 times negative 1 squared minus 5 times negative 1 minus 6. And this comes out as 0. So what does that mean? That means that negative 1 is a 0. Okay, and what that means is that x plus 1 is one of my factors. Okay, because I know that for sure, right? Because if I threw in negative 1 in there, then when this was in factored form, it would come out as 0. Okay, So now from there, what we want to do, since we know that that's a 0, we're going to use something called synthetic division to figure out what's left. Like after we divide x cubed plus 2x squared minus 5x minus 6, what I can do now is if I divide this by one of my factors, this x plus 1, then I should be left with, well, some quadratic after that, right? And the way we factor this is something, it's the easier method, is called synthetic division. So the way this works is we write down a line like so, and we put in our 0 at the top. So this would be -1 up here. So we know that this is like a factor that we have. And then we write the leading coefficients of all of our terms. So this would be 1, 2, -5, and -6. Okay. Then what we do, we bring down our first term, so 1. And then it's going to be this one on the left, so -1 times 1. And then what that is goes here. So that would be -1. And then we add these. So 2 minus 1 is 1. And then -1 times 1 is -1. -5 minus 1 is -6. -6. And then -1 times -6 is +6. And so now -6 plus 6 is 0. That should always be the case, right? Like if this actually was a factor, I knew that that was always going to happen. Okay. Okay, so what do these numbers mean? Well, these are now the leading coefficients, but we no longer have an x cubed term. It's going to be an x squared term for our leading term. So this would now be 1x squared plus 1x minus 6. And we don't really need the 1s there, do we? Oop. So plus. Okay. All right, so now what do we have left? Or what do we do here? Well, this is where we started, right? And we wanted to start factoring the second piece. So we went x, this cubic function here, we divided that by x plus 1 and got this. So that's what it's made of. So now let's write what is left here. So if we want to write this out, this is -2. One of the factors was x plus 1. And the other factor is this one, right? It's going to be x squared plus x minus 6. All right, so that's looking pretty good, right? But we may be able to factor this one down even more, right? And you guys have been doing this since grade 10. So let's see if we can. So this would be 2x plus 1. And then we're looking for numbers that multiply to 6 and add to 1. So this will be x plus 3 and x minus 2. All right, so there we go. We are factored, right? So we have completely factored this expression. So now this is greater than or equal to 0. So let's just write that again now. So this is supposed to be greater than or equal to 0. So where is this the case? Well, it's a little bit easier to see now because this is in factored form. So what I recommend doing here, there's different ways to do it, but the one I like to do is let's make a number line. All right. And then the next thing we want to do is we want to write down where our x-intercepts are. So think about this number line I just made as like pretty much the x-axis. So we can see our x-intercepts here. So we're going to have an x-intercept at x is equal to -1, -3, and +2. So -3, and then over to -1, and it'll be 0, so then -2. Or +2, sorry. Okay, and these are going to be points on our graph, right? And these are really going to be where it crosses, right? So it might be above here, it might be below down here. So we're going to be able to figure that out. So now what I really want to do is I just really want to figure out, let's say in this section over here, like everywhere to the left of -3, let's say, does that come out positive or does that come out negative? That's all we really want to do here, right? So then we could throw any number we want in, and you'll hear this sometimes referred to as like a test value. So we could test, right? You could put in -4 for each of these. -4, -4, and -4. But, for the most part, it doesn't really matter what the numbers come out as. All I'm really concerned with is whether or not it comes out positive or whether it comes out negative. So if I threw in, let's say, -4 for a second, you don't even have to do the calculation to figure out what it is. We'll just do this. We'll say, okay, over here, this would come out, this would be like negative, right? You got like a negative number out front times, and then we're going to throw a negative here. So this number is definitely coming out negative, right? So definitely negative. So just throw like a negative in there. And then the next one, if it's less than -3, -4, for example, then that's also coming out negative, no matter what. And then over here, -4 minus 2, definitely negative. Definitely negative. So over on this side, I've got a -2. Doesn't really matter, it's 2, it's just negative. So negative times negative times negative times negative. It is definitely positive over here. Okay. And now if we look in this next section, right? So I want to just test out some number between -3 and 1. So -2 would probably be a good example, right? So you can just think about now, if I threw -2 in place of x here, so -2, then what we'd have is, so in this section you'd have -2 times, and then again, so -2 plus 1, so definitely coming out negative. This one is now going to be coming out positive, right? If you had -2 in there, so that would be positive. And then the last one, -2 in this last factor, would come out negative. So 3 negatives, that thing is coming out negative. Which is kind of what we expect, right? It crosses the x-axis here. So I was really expecting it to come out negative, wasn't I? You probably didn't even need to do that to really figure that one out, did you? And likewise, what do you think is going to happen over here? Probably coming out positive, right? Because if it crosses the x-axis, it's coming out positive, right? And you might think, okay, why are we doing this then? Well, it won't always do that. If it, like, let's say it's a rational function. If you had like a vertical asymptote or something, right? Maybe it would both stay like negative on both sides of that. Or if it was a whole or something like that. But in this case, with just a standard cubic function, yeah, it's definitely going to be coming out over here. But let's just look at it again. So then the test value, in this case, we could throw in 0. That's an easy one. So let's throw in 0. So if I threw 0 in for all my x's, then that would be, -2. And then the next one here would be positive. And then if I threw it in there, it'd be positive and negative. Okay, 2 negatives, 2 positives. This thing is positive. I knew it. All right. And then if we threw 3 in, so just test value of 3 for all these guys. So then that's going to be, so that'd be -2. And then we'd have positive for this first factor, and then positive, and then positive. So I've got a -2 times 3 positives. That thing is coming out negative. All right, so that's exactly like we were expecting, right? So now the last thing to do is actually just write this thing in interval notation. We are interested in where it is greater than or equal to 0. So that's over here, right? It's positive above, or when it's less than -3, and when it's between -1 and 2. So we just need to write that down now. So in that case, that's going to be, we'll start from the left. So we'll write a round bracket and then -infinity. Okay, so that's where we're starting. It's like we're starting at -infinity over here, comma, and then we're going to -3. So it's going to be 3, so it's because it's going to 3. Now the question is, do I use a square bracket or do I use a round bracket? So it really depends on whether or not it's greater than or equal to, or just greater than. If it was just greater than, then it wouldn't include 3, and you would use this. But since it's greater than or equal to, the way we show that it's equal to 3 as well is with a square bracket. Okay, so that's like the first chunk. And then what we do is rewrite the union symbol. So like that. And then we move on to the next chunk. So then the next chunk is in here. So then it's from -1, and it includes -1 because it's greater than or equal to, right? So then it's -1, comma, and then goes to 2. And there you go.